Yay. Well, hey guys, thanks for coming. My name is David Green. I'm an enterprise solutions architect based out of Los Angeles. And I've been in AWS for the last like three and a half years so far. And in my role as an enterprise SA, I help enterprises and customers either migrate data from on-prem to the cloud or optimize on the cloud, or also help prepare for large workloads. But one of my favorite things I like doing is, because I come from the infrastructure world, from like on-prem data centers, and I like talking to people about like this is how things used to be in data centers or are in data centers, and this is how it kind of maps to cloud, and help people there. We'll take questions after the session, so please ask questions and hang out. I'll be around. In our agenda today, so we're talking about Elastic Block Store, EBS, specifically in Snapshots. I'm going to spend some time going through EBS at a higher level as well, because that kind of helps to understand how the Snapshot service works and how we can kind of do the things that we can do with EBS. I'll talk also about some automation and snapshot management to be able to automatically handle the orchestration of snapshots. And also some other details about what you can do with snapshots, whether it's cross-region copy or cross-account copy. And we'll also talk about how encryption works. We take the feedback seriously too, so if I can encourage you just to take, at the end of the session, a couple of seconds to do feedback. This is a repeat of the first session from yesterday. And a piece of feedback we got was, it'd be awesome if there was a demo. So I'll show a couple of live demos. But we read every single line of feedback that's submitted, so thank you for doing that. So AWS has three core storage offerings. There's block storage, file storage, and object storage. And every time I do a session, whether it's here or at the global summits, every single time somebody asks me, it's like, hey, I want to share files to all my EC2 instances. Can I just use EBS as my file share? It's like, well, no, we have a file sharing service called EFS. So please, look at that service. However, you can have EBS and EC2 set up together as a file server if you wanted to build one, or look at partners who run on us doing the same thing. So block storage is, you write data using, block-based technology. So the easiest way to think of block, in my opinion, is just like a hard drive, right? So you have this hard drive, your system sees it as a block device. We expose EBS either over the PCI or NVMe bus. And you can do stuff like create file systems on it, have multiple together as a RAID or whatnot, but it's a block device. A file, we abstract it by a layer. So file we expose through like NFS. So you can mount it over NFS. Today we announced FSX for Windows, so it's Windows compliant file system. I also listed Storage Gateway here too, because Storage Gateway is a product that lets you access data that's stored in S3, but over file-based, so SMB and NFS. And of course, S3 and S3 Glacier, which are object-based storage. There's multiple ways to get data in and out as well. So we have multiple block storage technologies, which I'm going to go into, and we have lots of choices here. So in block, we have two offerings of block. We have what we started with, and we still have today, Amazon EC2 Instance Store. So Instance Store, it used to be called Ephemeral, so if that name sounds familiar, it's what it's Instance Store. It's the physical devices that are in the host that's running your EC2 instance. So it could be NVMe, SSD, or HDD-backed storage devices. And these are really good if you have cases for super low latency for sensitive workloads like that, like very, very low latency, or very high number of IOPS, greater than what we can do through an instance with EBS, or also for local caching. So for example, the C5D instances, anything with a D in there has a local NVMe disk, whether it's one or a few. However, on Instance Store, we don't support snapshots of it. And also, if that instance is terminated or fail, the data associated with it will be lost. But there's use cases that we'll go into. SSD-backed volumes for EBS, it comes in two flavors, GP2 and IO1. And also HDD-backed volumes, ST1 and SC1. And these are really good for sequential-based workloads. So I mentioned Instance Store is really good for high throughput. So Infor is doing this. They had a requirement to run, to shorten their backup times for Microsoft SQL Server-based application data. They have about 2 petabytes of SQL Server to back up on a daily basis, and the previous backups were taking too long to complete. So what they did was they attached ST1 volumes to the I2 instance. They ran their backups to the EBS volumes, and then from there they can use snapshots to persist that data to S3, because S3 has 11 nines of durability, for the storage for snapshots. So you can use this in a hybrid model. You don't have to choose one or the other. They can work well together. So what is EBS? It's block storage as a service. You can create and manage and attach volumes either through the API, CLI, SDK, the GUI. And it's a service that's accessed over the network. And that matters because as you size your instances, if you have a small instance and a super fast EBS volume, you can't get the full utilization of that volume because the instance size is not really set up to handle that. So you can look at that. We have online, we actually break down instance sizes and throughput and IOPS. It's HDD backed, and we also support encryption, so I'll go into that in a little bit. And point-in-time snapshot support. It's designed for 5 nines of durability and a 0.1 to 0.2% AFR, or annual failure rate. So to put that in perspective, if you have 1,000 volumes deployed, in 1 year you should plan to have 1 or 2 of them fail and not be recoverable. That's why it's important to snapshot. This is a Seagate 3 terabyte hard drive. On their website, it's a 1% AFR. So the AFR of EBS is far lower than hard drives. So a quick look at volume types of performance and cost. So IO1's our highest performance SSD volume. Just recently, this week, we increased the IOPS of IO1 up to 64,000 IOPS per volume and up to 1,000 megabytes per second per volume. To realize this throughput, please attach to a Nitro-based image, like C5, M5s, and we actually list out Nitro. On GP2, the other SSD-backed volume, we also increased throughput and performance. We increased 60% peak performance. So GP2 volumes larger than 5.3 terabytes have an IOPS increase of 10,000 up to 16,000. And throughput increase for anything over 334 gigabytes increased from 160 megabytes up to 256 megabytes. So realistically, across our fleet of EBS globally, we see GP2 solving for nearly all customer use cases and access patterns out there. So I would definitely suggest starting with GP2. On the HDD back side of the house, we have 2 flavors: ST1, which is our sequential-based throughput. It's designed for sequential throughput, and also designed for intensive I/O. ST1 is our lower-cost, colder option, so it's a bit more modest performance characteristics of that. A prior generation of EBS was magnetic. And what you can do also is you can move data types using elastic volume. So you can say, take data from magnetic volume, actually change that volume type to be ST1. And that's what's pretty awesome too, because with elastic volumes, you don't have to really worry about making the wrong decision. You can start, like I said, start in GP2, and then if it's not performant enough, you can switch over to IO1. You can actually modify the number of IOPS of it as you need to, whether it's increase or decrease IOPS, change volume type. So some cases we see if you're collecting like time series data, you can then switch over to a lower cost HDD-backed volume. And the reason I kind of wanted to show you that and go into it is really emphasize that EBS is like a hard drive, but it's not a hard drive. It's really designed from a service. So it's a service that delivers block. And in the service, it's a highly distributed system. So we have multiple devices in the service that make and expose your volume. And that's really important too, because it allows us to do things like elastic volumes and also the snapshot services. EBS is available within an AZ, an availability zone. So you can attach and detach volumes within an AZ with each other. EBS is also decoupled from EC2. So that allows you to size your EC2 instances accordingly and not have to worry about any throughput considerations of oh, the only way I can get higher throughput is to have this type of instance with this many disks. Where it's not like spindle bound as if it was in the on-prem world. And we see customers detach and attach all the time, whether it's to have a higher power EC2 instance, or even like for Cassandra rebalances, we see customers get a higher power EC2 instance, do the rebalance, and go back to a smaller instance. So you can kind of do some cool things here. You can attach multiple volumes to one host at a time. However, one instance can have multiple volumes, but one volume can only go to one instance at a time. We definitely suggest separating out your boot volumes and your data volumes, so that way you have a clean, nice, small boot volume, and your data volume can be sized and snapshotted and kind of set up as data. So snapshots, snapshot creation. I'm sure you guys know this, but just a quick high-level overview of the creation process. In the EC2 console on the bottom left, click on Volumes, and then click on Actions and select Create Snapshot. The console changed in the last year or so. So basically now we expose the ability to add tags upon creation. This is true for the console and also through the API and CLI. Definitely tag these, because you can go into some things such as cost allocation tags, which I'll show you as well. So you can actually do cost reports based on tag, and you can automate the snapshot process based on tag as well. When you click Create Snapshot, you get this, and it's basically saying Snapshot creation started. This happens typically in low single-digit seconds. Realistically, it's faster. Please test in your own environment to confirm. But what happens is all the data that gets collected in the snapshot is captured here. So as soon as you say Create Snapshot, you get a 200 OK back, or this screen that says Snapshot started. Anything that was on the disk at that time is captured in that snapshot. And to view snapshots, on the bottom left, under Volumes, you click on Snapshots, and that's the only one I had in there at the time that I just made. Also, on the third line down, it says encrypted, because the initial volume was encrypted. So you can actually create snapshots, and by default, if it's encrypted, the snapshot's encrypted. On the CLI as well, it's very similar. Create snapshot, I specify the volume ID. I'm adding a description tag there. And you can add more fields here as well for tags. They do the same thing in the console. It just took up a little bit more screen space, so I couldn't fit it in here. And to view snapshots is similar. So I mentioned when you get the 200 OK back, or the console says creating snapshot, anything that was on the disk is captured by that snapshot. And it's called crash consistency. So the easiest way to think of crash consistency is if you were to, let's say, unplug the power cable out the back of your server, and anything that was on that hard drive when the power cable was unplugged is on your hard drive. Anything that was a memory that was not yet flushed back to disk is not going to be on that hard drive. And it's crash consistency. And that works, that works a lot of time for customers. So if I would really, depending on what you need, look at both ways. This is called application consistency. So app consistency actually flushes the data from the application, in memory, to the volume. So that way when you take a snapshot, anything that was in memory exists on the volume at the time of the snapshot. Now the question is, does it stop the volume during the time? So there's a couple ways, and I'm going to get into that here. It is actually next slide. Yeah, look at that. One of the requests we got was to support VSS-enabled snapshots. So with Windows, VSS allows you to actually handle the snapshot process. So VSS-aware applications can actually handle this and move it, application memory data out of memory into disk and handle the snapshots. And with VSS, we pair it with SSM, which is Amazon Systems Manager, and SSM lets you run commands across a fleet of hosts. It means that you don't have to use native tools like SQL backup, or even develop and maintain your own scripts. So to do this, we're going into the EC2 Systems Manager window there, and we're selecting the command create VSS snapshot. There's some other cool commands here as well, such as like run bash script. So I use this a lot for doing testing across a bunch of hosts, run a bash script across host. You can also do this across a percentage of hosts at the same time, or do them all at the same time. So you don't have to worry about, something failing catastrophically if you do maybe, a few percent each time. And catastrophic failure for me is running bash scripts, not for running snapshots, by the way. So you select the instance and you add tags. So for example, a tag could be, it's a key value pair for tags. And there's also a checkbox here that says allow you to exclude the boot volume. So you can say snapshot all my data volumes, don't worry about snapshotting the boot volume. And then when the run command makes a VSS agent, it actually flushes I/O and handles all the process there. You need to have a policy set up. So policy is only 3 things: describe instances, create tags, and create snapshot. So snapshot scheduling. Last year at reInvent, when I talked to you guys about snapshot scheduling, it was an older way. It's the old way. It looked a little bit like this. We use tags just like we saw with VSS. So you have a tag that says snapshot volume, yes, or some tag like that. We'd have a Lambda script, maybe fire every hour or whatever frequency you want through like a Lambda schedule, almost like a cron job with Lambda. And optionally, you can do the EC2 run command to maybe stop I/O. With Linux, you can do a flush and freeze. And that worked, but customers said, it works, but it's kind of a pain to manage at scale. Like, is there anything easier for us to do? So this year we announced Amazon Data Lifecycle Manager, or DLM. And DLM automates all this for you. So it automates the creation of snapshots, the automation, retention, and optionally you can delete snapshots. And it's policy-based. So you have regular schedules you can use. And you identify using tags, so it's still similar as before with tagging. And you can retain backups for compliance or audit requirements. So you can say, for example, I have to maintain the snapshot of this thing for 30 days or longer. You can automatically do that here. You can control costs by automatic optional deleting of snapshots. And I'll go into some detail here next. And use IAM to control access. So that way, for example, you can allow access to delete only by specific trusted accounts, and maybe you don't want to have everybody have delete access. And there's no cost. You're only paying for the data that's stored in the snapshot. So here's a couple examples. Let's say the customer says, I want all my EC2 instance root volumes to be backed up on a daily basis and saved for 7 days. So basically, it's like a rotating 7-day window of snapshots. The policy looks like this. We have a tag of the tag key named vol type and a value named root. We create every 24 hours. In this case, we're starting at 7 UTC, and we're keeping the most recent 7. A second example here is I want all finance or accounting data volumes backed up every 12 hours and kept for 10 days. And that's kind of what it looks like. And it's kind of cool because you can actually have it use multiple tags. So in this case, we're actually looking for anything that matches Department of Finance or Department of Accounting, then do this, with 12 hours. And here's a quick look at what this looks like. Cool. So I have my volumes here. Under the left side, I'm going to Lifecycle Manager. And I already have one created, so I can just show you what this looks like here, and we'll make a new one real fast too. So the window here shows what it looks like. So we have the policy information and the summary here. So every 12 hours, I'm creating a snapshot at 0900 UTC. I'm keeping a max of 28 snapshots. And then the oldest will be greater than or equal 12 weeks, 2 weeks, sorry. So here's how I create it. I'll make a new one here. Description, demo, and then I'm selecting tags. So let's say I want to have a tag named like environment. So I have my environment, and I want to match prod. So So anything that matches my production environment. Schedule name, I'll say every hour. Just gotta do that. Oh, it's every 12. 12 hours, like 12. You can change this when, whatever time you want it to start. Number of snapshots are retained, so we'll just do, I don't know, 5. And this is neat too. So we have the ability to copy the tags from the volume. So I'm heavily encouraging tagging. So if you have your volume tag with, cost center, application name, environment, whatever else you want to name the volume, when you create the snapshot using DLM, it takes those tags and actually applies it to the snapshot as well. So you can still have the values of those tags all in there. Optional, you can make more snapshots too. Like David's, I don't know. All right. And this will be tagged as well, up to 50 additional tags you can tag to the volume after this process. By default, it's enabled, hit create policy, and it's out there. Go internet, there you go. Okay, so if we also look here at the snapshots that exist already in my account, I did not do a name tag, which I should have here. This is kind of what it looks like. In my existing policy, I did not actually copy the tags. I did have I'll show you this real quick too. In my existing policy, I had one that was adding a tag called snapshot automatically created every 12 hours. So if I go back and look at my snapshots, I actually see that as a tag here, automatically created every 12 hours. So it's easy to kind of tell what was done by me doing this versus me manually taking snapshots. And this shows the same thing, so we'll skip these. Sorry, guys. Okay. So now I'm creating lots of snapshots on my account. I have at least 28 per match that matches that volume. And it could be easy to think, that sounds expensive. If I'm taking snapshots cost 5 cents per gig in a snapshot service. I'm taking tons of snapshots now automatically. Is this manageable? So every EBS snapshot functions as a full point-in-time snapshot, full point-in-time backup. So that means you don't have to do stuff like daily incrementals and weekly fulls or whatever the process may have been. Realistically, every single snapshot you take could actually function as a full point-in-time snapshot. And to minimize cost, the snapshots are incremental. So you're only billed for unique data that goes into the snapshot service. After the session from yesterday, somebody came up and was like, hey, I had, I don't know, like 60 snapshots, and I deleted 40 of them. And my cost is about the same. It didn't really go down. I thought that I would, go down by a large margin. It's like, well, no, because basically the data that you put into it, if it's the same data, we're not billing you for every single time you back up that volume. It's only unique data that hits the backup service. So here's a look at what that looks like. So you have your EBS volume, you take a snapshot, and the snapshot service lives within the region. So it hits the snapshot service, and then the snapshot service writes to S3. So we use S3 as our backend store for the snapshots. It's a block level backup. And S3 is part of the service of the snapshot service. So what that means is you can't go and browse your own S3 bucket and see all the blocks that we write, because it's our bucket as part of the service. But it allows some cool things too, right? Because S3 has 11 nines of durability. You do encryption at rest, encryption in transit, so everything's encrypted and safe. So I mentioned you're only billed for unique data that hits a backup service. So let's say I create my volume. This is a brand new volume I just made. It's empty. Let's say it's a terabyte volume. I take a snapshot, and it's empty. There's nothing in it. And you're billed for nothing because there's no data in it, no blocks have changed. You take your first snapshot, it's empty, you're not being billed. The AWS console, the GUI actually shows snapshot size as 1 terabyte, but it's not being billed for a terabyte. We just show the volume size that was snapshotted. And that can actually be proved out as well through the detailed billing report, the CSV file, or through the cost explorer, which I'll show you. So empty volume, empty snapshot. I'll add some data here. So I'm adding 1, 2, and 3 onto my volume. I'll take my first snapshot. So of course, first snapshot is essentially a full backup, right? You're taking everything that existed on the volume, you're moving it into the snapshot service, and now you have 1, 2, and 3 as snapshot number 1. Let's say we delete data. So I'll delete data 1 and 2. I'll take a second snapshot. And before I take a snapshot, 3 already exists on the volume and 3 already exists in the snapshot service, right? I'll also add some data here as well. So I'll take the snapshot, and because 3 already existed in the service, we're not copying it again, we're not billing for it again, it's already there. And we only copy over the changed data, so we're copying over 4, 5, and 6. Well, let's say you delete a snapshot. What happens? So if you delete a snapshot, only data that's exclusive to that snapshot gets deleted. So in this case, the only data that exists in snapshot 1 that 2 does not have, and that's not on EBS volume anymore, is 1 and 2. So let's say we execute that delete. Because 3 is part of snapshot 2 already as well, we actually just reference it in the snapshot. So it's all part of the snapshot service. We're aware of what existed on all the snapshots, and we don't have to, it's not really worrying about like multiple fools or some, maybe how things are on some backup applications. It's all just handled through the service seamlessly. And when you delete a snapshot, it's gone forever. Like there's no undo, delete snapshot. Like when you delete it, it's gone. So I'll do some more work. I'll delete 3. I'll add 7, 8, and 9. Let's take another snapshot here. Again, 4, 5, and 6 already exist in the service. We're not going to copy that twice. We just reference it, and then we add more data. So that's kind of what goes back to why he's like, well, how come I don't see a huge data loss or a cost savings? Because I deleted all these snapshots. So, well, we already had it in the service. It exists on the volume. It's already there. Well, how about encryption? When you enable encryption, the following types of data is encrypted. So I don't know if you guys heard the talk from Peter DeSantis. He talked about the Nitro system. So Nitro does a lot of the offloading for EBS, or there's a ton of offloading there. And a benefit of Nitro is you can get line rate encryption across the EBS volumes. And there's no penalty for using it. There's no data, there's no overhead, there's no cost, it's free. It's just pretty awesome. Encryption also is at the volume level. So the volume itself is encrypted, and the data inside the EBS snapshot is encrypted as well. So this summarizes what I was just talking about here. It's encrypted. It's fairly easy to use. Some interesting things here as well. You can copy an unencrypted snapshot that you own and encrypt it during a copy process. So if you have snapshots that are not encrypted, you can just make a copy of them and apply whichever key you want to apply, and create encrypted snapshots of what you had as previously unencrypted volumes. And also, when you copy an encrypted snapshot that you own, you can re-encrypt it using a different KMS key. And this is what it looks like when you create the volume. So to create an encrypted volume, I'm checking the encrypted box halfway in the screen, and I'll just zoom into this section here. So by default, there's a master key here called the default AWS EBS key. And this key is used if no other key is specified. And this is fine in multiple cases. So if you have a requirement to say, all my data in my EBS volumes and snapshots must be encrypted by, maybe compliance or policy-based, it's super easy to accomplish this with a checkbox. But for best practices, we suggest that customers create their own KMS key. Because by creating your own KMS key, you can do stuff like define the rotation policy, you can control or get access through CloudTrail auditing of use of the key, and you can control who can use and admin the key. So for example, if you have a policy that says, all keys must be rotated every 3 months, you can do so, using KMS. So to do this, I'm in the IM console. On the left side, I click on encryption keys, I make my own. I made one called EBS-master with a description of, master EBS encryption key. So now I'm back at the volume creation page. In the drop-down menu, now I have two options. I have the default one that exists by AWS and all the accounts that you'll see just, I'll have it just exists. And then I'll have my new one for EBS master. You can also run instances. So run instances when you actually launch an instance. So you can launch an instance with a encrypted volume as the data volume. So you can click and say drop-down menu and choose your key for encryption. And that's what it looks like there. So how does our encryption work? We use a process called envelope encryption. So envelope encryption is a hierarchy of encryption. So the master key is stored in the KMS service, and it never leaves KMS. So a master key lives in KMS and never leaves. And then it allows you to encrypt one data key per volume. And every volume has its own data key envelope encrypted by the master key. So when you want to use a volume and attach it to an instance, first we check with the service to make sure you have the ability to decrypt it. And it will decrypt and put the metadata into the EBS volume and the instance running and your running instance. So what that means is all the data I/O, the I/O path goes from your EC2 instance and the EBS volume without having to go through like a KMS service around a loop or anything like that. It's also great because it reduces your blast radius. So let's say something happened, a key got out, and yeah, we see crazy things, people putting code on GitHub with keys in it and just things that people should not be doing, so please be careful. But let's say that happened. If this is the case, you'll lose, your exposure is only a single volume. You're not going to have exposure to every single thing that master key encrypted. It's only that one single volume blast radius, which is pretty helpful. So we hear customer feedback, and we take feedback to help shape a roadmap. And one of the things was, hey, that's cool that you can create an instance that has a data volume that's encrypted, but we want our boot volumes encrypted as well, super easily. So I'm happy to announce that we have the ability to do this as well. It's in public preview. So if you're interested in this functionality, please email us, ebs-encryption-preview@amazon.com. And what that allows you to do is launch encrypted volumes, encrypted EBS-backed instances from unencrypted EBS AMIs. So what that means is, if I go to like the console and say launch instance, I can choose Amazon Linux or Windows or Ubuntu or whatever else is in there, and then launch it as an encrypted backed instance, which is awesome. Because before you would have to create a snapshot of it, encrypt it, and then launch it again. And the feedback we got was, hey, it works, but it's not awesome. So please help. So yes, that's available today. Please email us to get signed up. So what things can you do with EBS snapshots? From an EBS snapshot of an instance, you can create an AMI. And an AMI is like a blueprint of your machine. It's called an Amazon Machine Image. And from there, you can make one or many EC2 instances. So for example, when I go and launch Amazon Linux, it's coming from an AMI. We can share AMIs between accounts. So in this case, I'm showing creating an instance or multiple instances. You can also have your EBS snapshot hydrate a data volume, EBS data volume, and attach it. So some cases we see here, customers taking snapshots of data, whether it's like data for like images or their data set for processing, and they can attach it to multiple, create multiple volumes, attach it to multiple instances for compute. I also do this for some of my testing. I have known data sets I like testing against. I'll just save it as a snapshot and then create it quickly as a volume. You can also snapshot copy between availability zones. So like I said, an EBS volume lives within a region, an AZ. So you can mount and unmount within the AZ. But if you want to move it between AZs, you create your snapshot and you can copy it between AZs. You can also do the same thing across regions. So you have your snapshot. Let's say the left side is US West 2 in Oregon. Right side could be Dublin. You can copy between regions and create volumes from there. And we see customers do this for a few reasons. We see customers do this to either have their application, snapshot your app, and have your application live in multiple AWS regions for high availability or just their application requirements. We see this also being used for things like disaster recovery. So let's say you have a main production region in Oregon, and you want to have your snapshots live in other regions. That way, if you need to, you can spin up the infrastructure or run in an active mode based on your business requirements. So let's look at for snapshot copying. So because the snapshot service is backed by S3, all the encryption is handled for you, and also the in-transit data is also encrypted through the S3 service. The first copy to another region is always a full copy, just like how the snapshot of the first snapshot is going to be a full because you're moving all the data that didn't exist to the new location, and that also is true here as well for snapshot copies. But what's cool as well is that the incremental snapshots are only incremental, so we're not doing full copies on every single one. And to make this happen, this is also true for encrypted snapshots as well. And for encrypted incremental snapshot copy, you must use the same CMK key to support that. This is a relatively new launch, so you may not have seen this like a few months ago, and somebody from the last session too said, I think it used to be full copies, it was expensive every single time I did this. It's like, well, now with this, it's incremental, so it's going to be the same cost savings as you would see within the same region. Well, speaking of cost monitoring. I mentioned it's really important to tag everything. So please tag your environments, tag your instances, tag everything you can in AWS. But especially with tagging for snapshots is you can enable what's called a cost allocation tag. And you enable this in your billing console, and I'll show you what that looks like. And by activating the tags, you tell us to say, report on this tag. Here's a quick look at what that looks like. Oops. Okay. Cool. So under here I do billing dashboard. On the top left side here, it's called cost allocation tags. And I have a ton of tags. And you'll see on the right side, I have 4 that are active. I have environment, I have name, I have cost center, I have one called snapshot. And I have a ton more tags here, right? Like CloudFormation tags, other things here like customer tag, directory ID, and it says inactive. So we're ignoring that. So if you want to have us report on it, please make sure that it's active, so that way you can get your snapshot data in your dashboard. So here's kind of what it looks like. I have minimal usage here of snapshots. So from snapshots, I have one called no tag and also one called prod, because I'm not really snapshotting anything else right now. It's minimal, so it's a non-production account, so it's not really fun to look at. But you get the idea. Once you have multiple environments or multiple cost centers, you can see here. Customers say, hey, I don't know how much my staging environment costs, or my QA, or dev and test or whatnot. Like, how do I reduce costs? And like, well, this is super easy. You just enable this. You can get a visual representation of what's being used, and kind of dive in and see what's where you can save some money. You can also export the data through a CSV using detailed billing reports. And there's some use cases online where you can take this data and put it into QuickSight to be able to drive a experience through like a business intelligence tool. So also with cost reports, you can see your EBS volumes here as well. So in this case, I'm showing EBS IO request and also provisioned IO volumes. So starting in August, I really picked up my usage of the IO one and the IOPS provision volumes here. And it's super easy to do this, so I can actually search on EBS, let's say GP2 type. Yeah, here's my GPT usage. So something happened in July where I had a spike. So it makes it really easy to dive in and search. You can get much more granular through the CSV as well, but this is a really easy tool to use. But again, please be sure that you enable this. I'll show you what enabling looks like. You just click on this and activate it. It's super easy. So now you activate that as a cost tag.
I'll also show you here real quick as well. You can search the EBS snapshots based on tags. So I have a tag here that says every 12 hours. Actually, here's all my snapshots. And I can just search hours. You know, just a partial search of the tag, and I can show what I found here. So whether it's for environment, let's just try, yeah, prod is this. So environment tag prod. So it's pretty easy to use, and it's you know it's really easy, no cost there. Cool. So in closing, if you only get 3 things away from this time, please do these 3. Please tag everything. It makes it much easier to see what's what. I had a case even just now. One of my volumes was not tagged, and I didn't know what it was. So I basically had to click on the instance it was attached to and find out what the instance was, and hopefully that was tagged. And imagine this at scale, seeing a bunch of volumes, not knowing what it is. Can I delete them? It's not fun. And automate. Use DLM to create your snapshots for you automatically. Even if you only snapshot and keep them for a day or a week or a short time, the more you snapshot, the faster snapshots complete. So if you have some catastrophic instance failure, it's really easy to get that data back. In demos and testing, I often find that I'll make mistakes, and it's faster for me to get data back off a snapshot than it is for me trying to go back and fix config files and whatnot. So it's really easy to automate and leverage that. And encrypt. So encryption is literally a checkbox, and there's no penalty for encryption. There's no performance impact. There's no cost impact. Just encrypt. So that way, in the future, when someone goes, "Oh, hey, our new policy is all data must be encrypted." Oh, cool. It's done already. It's a checkbox. So with that said, thank you very much for coming to this session. I appreciate your time today. And I did this on purpose. I finished a little bit quick to do some questions. If you have any questions, please, please ask. Yeah.
You say incremental, so like snapshot A, snapshot B. If there's something that was deleted since snapshot, when snapshot B is taken from snapshot A, is that deleted data in snapshot B?
Yeah, so the question is, if I had snapshot data in 2 snapshots, and if I deleted data before the second snapshot was taken, yeah, so as long as the data was snapshotted once and lives in the snapshot service, it exists. If you delete the snapshot that only has that data, let's say no other snapshot ever has that data but one, if you delete that data, or that snapshot, the data will be gone. But if you take snapshots on a daily basis, or a regular interval, and basically, again, anything you delete is exclusive to that snapshot.
So when I hear incremental, I think of everything as like a delta almost.
It is, yeah. So incremental is like a delta. So for our side, we see it only as blocks, not files. So if a block is new, we'll back that up as the new snapshot. So we're not doing full, full copies or anything like that. Yeah.
So you showed if you have a Windows-based host like AWS, but if you have a database based on Linux, like is there any equivalent you can use?
Yeah, question is if you have Windows-based host, VSS works for application consistent snapshots. If you're running Linux and a database or tools, for Linux and databases, we see customers that are using either there's a couple ways. Customers will do like a database dump to another volume and snapshot that volume, or you can do things such as FS freeze and sync to really write all the data out of memory to disk and snapshot that. Again, because the snapshot completes in literally, it captures the data in, I don't know, it's like a second or a few seconds, you don't have to freeze that long. So as soon as you get the OK back or the snapshot creation back, you can resume I/O. So if you have a system that requires you to do that, it's only like a few seconds you have to freeze and sync and then unfreeze. You can also do regular snapshots to another volume and just capture that as like a regular part of the database service. Sir?
I have a question for you, David. You have an example with when it was a snapshot of one and afterwards the second one, which is an incremental. Let's say, for example, I have 4 incrementals, right? Is there a way through the CLI or through the console to see what's the difference between the incremental snapshot and the full, because sometimes it, yeah, it would be useful to see not the block size, but the difference as in, I don't know, gigabytes or something like that.
Yeah, so question is, if you have multiple snapshots, snapshots are incremental, how do you tell what's different between the two of them, right? Like, so we don't see files, we only see blocks, so we can't say, you know, this file changed, but we can report on the size of every snapshot. I need to check and see if it's through CLI. I know for sure we report it through the detailed billing report in the CSV, so you actually see all the snapshots and the size of every single one. Actually, in the, let me just check here real quick. Yeah, we don't show it here. That's what I was saying earlier. Like the capacity shows 8, the size of the volume. We don't actually report the capacity of that snapshot. So that's why it gets confusing for some, because they go, hey, you know, it says a terabyte and it sounds expensive. But no, so the way to see that today would be actually through the, it would be through the detailed billing report through CSV. But what would be helpful too, on the bottom left side of all the AWS pages, there's a feedback button, and we read all those. So if you say, hey, it'll be nice to be able to show like the delta, like the diff between these two snapshots, like that helps us to build the service. And I'll also give that feedback to the product team.
Okay.
Sure. Yeah, thanks.
Is there a way to set up DLM as code somehow?
Yeah, so the question is, can you set up DLM as code? So basically everything that the console does is just calling APIs, so yes. You can set that up through that, and there should be documentation to support that. Yeah.
You may have answered this already, but if I'm taking a snapshot, I've got an instance with 2 volumes, OS and data.
Yes.
And I want to snapshot them. This is a Windows machine. Can I do, like in VirtualBox, if you can do a snapshot that contains the memory and the data, so you basically restore the whole machine? Or do I need to use the other service? I can't think of it. Does the
Okay. So the question is, if I have like a host that has a boot volume and a data volume, is it possible to kind of capture the entire thing as like one entity?
one thing that you might restore it as a group, you know?
Yeah, you should be able to. I need to double check on exactly how that works.
And the other part of that is, do I have to shut the Windows machine off?
Yeah, so question, do you have to shut the machine off the snapshot? So that kind of comes back to application consistent snapshot versus crash consistent. So for the best experience on Windows, I would personally shut down and snapshot. You may not need to, but I would test also. You might not have to. Also in EC2 console now, we support hibernating a machine. So basically, it preserves the machine in a memory state as it was, so not like on a disk, but actually in the memory as the machine. Yeah, so other use case for the hibernate is also through like spot instances, right? So let's say you have some super cheap spot bid, and if you get outbid, you can now hibernate that and not lose. Before you have to like checkpoint data and kind of afford, you know, plan for being potentially terminated. But hibernate's pretty awesome.
Is there a strategy for long-term backups? Let's say right now the EBS snapshots is still basically a region of itself.
Mm-hmm.
Now I have to preserve images in Glacier.
Mm-hmm.
So do I have to go the hard way, like restore to MI, create EBS and then back this up to the state?
Yeah, so the question is there a long-term plan for your EBS snapshots? So if you want to have, you know, for reasons to maintain the,
Inside of EBS store, because I don't want to inherit
Yep.
this with the instances and volumes. It's been there, than that.
Yep. So like, is there a plan to like basically take EBS snapshots and put them to a lower cost, like deep archive such as Glacier? Yep. So that's something that we hear often. I'll definitely feed that back to the team. The answer today is no. The answer today is it lives in the service, because we basically plan to have anybody say, you know, restore this instance, and we don't want to have like, you know, any delay in that process. That is a request that we hear, and the only way to do it today is, I mean, there's some code that's on GitHub that does this, but basically you attach a volume and you can DD it into S3 and tier it into Glacier. So it's not awesome. People do what they need to, but it is feedback that we get though.
Quick question. If I need to get a whole inventory of what are my single instances, how many volumes are attached to the each instance, because if something goes wrong, you need to break the live
I'm sorry, I didn't fully understand the question.
So is it how to get inventory of all the EC2 or like whole environment, which are the snapshot attached to each instances? So basically, we can restore the environment once something goes wrong using all the snapshots. Is there any UI or direct tools available other than command line? I know, but is any better thing available through the GUI or console that will tell us like exit report of your exit attack from EC2 instances and everything?
Yeah, so questions like basically snapshotting an environment, right, of like everything, like the instances, all their attachment information, the volumes. Honestly, I don't know if we have anything natively that does this, like out of the box as something. In my last session, somebody was saying they have some tool that basically snapshots an entire VPC. I don't know if it's an open source or third-party tool. I'm sorry, I wish I knew more on that, but I'll feed that back as well.
Yeah, my goal is I'm designing solution for like the whole account. I don't care like this is a production account. We should take backup of each EBS volume that is attached to the instance because EMI is one option, but EMI is not like visible solution when you are encrypting and getting back with a lot of people are having a lot of issue to restore instances from the EMI. So if we go with EBS volume path, then we should have it like whole different auditing report ready, like say how we can restore whole environment, something goes wrong or something.
Yeah, I mean, you can restore, I mean, you can store more than one. You have, you can orchestrate it. I don't think out of the box we have like a mechanism for it, but also the, yeah, it doesn't, yeah, I'll feed that back to the team. Sir?
What are you guys going to support with the lifecycle manager more than just 12 and 24-hour increments?
So the question is supporting more than just 12 and 24-hour increments for DLM. That's feedback we get too, so I'll feed that back. What kind of like, granularity are you looking for?
Systems that do a weekly release on, right? And so I just want to get a snapshot right before that release in case something goes wrong or something failed out.
I mean, so the use case is like before you release, you want to snapshot before the release. That way you know the state. So if anything happens, you can kind of go back to that known state. So for the service, we can look at adding like more granularity to the schedule for DLM. In some cases too, we see people orchestrating this through like just through the API or just through the command line. So basically, before you push to prod, just trigger this.
I was bummed because I just gotten done written all the lambdas to do EBS snapshotting and then pruning and all that, and then came out with this. But then I was relieved when I found I didn't do exactly what.
So it's like okay.
We have to write our own to do like weekly, monthly, and
Right.
Yeah.
cleanups and everything.
Yep.
Patch shows, so. That would be nice to see the DLM more than 30 days granularity and then on demand.
Yeah. No, feed it back.
Yeah, I mean, just like a cron scheduler, kind of like the events
Cloud which
yeah, just how that works.
Yeah, and I mean we can too if you want to just do snapshots and just have a shorter retention on it, so that way it can still go every day, and then ideally it's still before you push.
I guess it's a policy, right? Which is the autopilot. Sure, you can do it by hand, do cleanup by hand, but why?
Yeah.
DLM has a policy, why bother? Why do it?
Yeah, exactly.
I mean, I guess, so what you're saying though, based on the information here, it's a relatively static volume, some code changes and some minor other things. So if we're taking snapshots every day, we're not actually necessarily paying for copies of data, right?
Yep.
So nothing's changing, we'll have a new snapshot, but we're not actually being charged anymore.
Yes.
Okay.
Yeah. So basically, if it's pretty much the same data, if you have tons of snapshots, it's the same cost as if you have one.
And you said that the billing report will enumerate the snapshot sizes and how much they're.
Yes. Yeah. Yeah.
That's the second and last question for you.
Yeah. Thank you.
Is there a way to export the snapshot into an OPP file template? Like, for example, we import it in virtual blobs because you said they are stored in an S3 bucket. Do I understand that?
Yeah, so the question is, can you take the snapshot from the snapshot service and export the snapshot as like a volume that can be used as a...
Because I can import my OPP image into the Amazon
Mhm.
console, right? I would like to be able to do the same and export for
I do not believe that's possible today. I'd like to talk to you after about or maybe submit feedback as use case. But basically, the service just holds all the blocks. We could look at potentially someone that could do that, but I don't know if it's on roadmap or not.
Is there a way to create a custom AMI with EBS for you? There is no such process, right?
Like custom AMI? Yeah, you can create an image. So Yeah, so if I have my boot volume, you can do create image, and create image will actually make an AMI. And they'll land here. Your questions on this side? I'm ignoring this side.
My question is, so I've heard today a lot about the encryption of volumes, and my question is, why it's actually required if there is some policy limits and so on. So is it not safe enough to keep not encrypted volumes with Amazon?
So the question is why, like basically why encrypt, right? Is it not safe to keep unencrypted volumes? Security is our #1 priority. We call it like job zero, because without security, we can't have a business. Realistically, the reason that people do encryption is for their business and their policies for the business. So if they have like a security mandate from like global, corporate security that says, hey, anybody storing any data must be encrypted at flight and rest, then that's how you solve for that. Data, again, security is our #1 job, and we won't launch a product that's not secure.
Or just company policies?
Realistically, yeah, company policies really drive that functionality. Yeah.
What happens to snapshots in case of automation stack is destroyed? That was part of the stack.
Yeah, so the question is what happens to snapshots if your CloudFormation stack is destroyed? So snapshots will still exist even if you terminate instances. So I've actually terminated a bunch of stuff today before this, and my snapshots for those still exist. So the snapshot will live in a service, and then you can restore from that if you need to.
RDS destroys the backup.
Oh, RDS? Okay. Yeah, EBS should not. So this EBS is just inside as a snapshot here. Yeah.
When you restore the snapshot, we say a new image for you've taken a snapshot of the mask and pressing completely to you want to go back when you took the snapshot.
Well, how do you restore a snapshot to be a volume again? Yeah, here I'll show you. So let's say I have a snapshot here. It's a 60 gig volume. Yeah. So what I'll do is I'll say action create volume. So I'll create a volume from that. And what's also nice is when I create a volume, I can choose a different volume type as well at creation time. I can choose my AZ. So this is in Oregon, so I'm looking at my 3 AZs here, so I can actually choose the AZ. And again, because EBS is tied to an AZ, just make sure that you put it in the AZ that you want it in. And the easy way to do that, I kind of cheat and look at this. So let's say I want to attach it to my, my VFX workstation. This is in AZ2A. So when you launch, just make sure that you put it into 2A, and you actually name things too, like right, and create volume. And now your volume's been created. I'll give it a sec. There it is. And I can immediately attach it. So if I go to my instance, here I'll show you this real quick. Go internet. It's always a thing trying to do live demo. Actually, so I have in this instance I have a 8 gigabyte NVMe volume attached, right? And that's how we expose GP2 on these instances. So what I'm going to do is I'll go back to my volumes. Let's test, right? My new one here, and this is the same one, right? So it's created today, November 28th. The state is available. So anything that's green is attached, anything blue is not attached. So what I'll do is I'll say attach volume. Instance ID is Bastion.
And you can potentially attach it to a different EC2.
So I'll attach it, and then I'll hop back over to Bastion, and now we see it attached. So there it is. And it's super fast, right? You can do this, you just saw how fast it is to attach to volume, and you can start using it out of the gate. I don't know what's on it, so I don't want to mount it and break it. It might be something else that's not, I mean, I don't know what data is, but yeah. Yeah.
So the snapshot that you only mount the data, you can write to the snapshot.
Yeah, so the question is, can you write to the snapshots? No. The snapshot is written to through the service when you actually snapshot the volume. Thanks for coming. And then but what you can do is you can write to this volume that we just made, make your modifications, and snapshot that.
And another question, is there a performance degradation for mounting the snapshot compared to the volume?
The snapshot volume, like the formatting of the snapshot?
No, right now the snapshot that you see the original volume is blocked. So when you mount it, is there any performance?
Okay, the question is performance. So the snapshot data lives in S3, and then the volume itself lives as a block device that's attached to your disk. So when you create a volume from a snapshot, we basically do a lazy load of data from S3 into the EBS service. But what you can do to expedite that, there's a couple of things. One thing is you can run FIO and do a random read across the disk if you really have to accelerate data in. Otherwise, it's usable immediately. Like you see all the data, it's there, and we start loading data. But basically, we prioritize and expedite the load time based on what's being accessed. And you can kind of spoof the service, if you will, by doing a FIO, like random read across the device. Another way that you can do it as well is by choosing a fast volume, right? So let's say you need data back quickly, use an IO1 volume, like a super fast, spec'd out IO1 volume. And then once data's there, change your volume type using elastic volumes to whatever volume type you want. Realistically, you are probably fine for performance. It's not going to be bad. But in the edge use cases that we see, where if you're like, hey, I want as much I/O as quickly as possible from that snapshot, look at doing something like FIO. And you can monitor that as well over CloudWatch logs. So you can actually tell, watching the metrics, when it's hydrated. And thanks for coming, guys. There's a talk from last year where I show slides of how to do this as well. Cool. Well, I think we're at time, but thank you guys so much for coming. I really appreciate it. It's always nice seeing people interested in block storage. Thanks.